Hello, awesome Algebra 1 students, and welcome back. In this short video, we're going to be factoring four-termed polynomials by grouping. So the steps are to first set up your groups. You're going to group the first two terms together in a binomial and the second two terms together in a binomial. Then you're going to factor the GCF from both binomials. If you haven't seen my video on factoring the GCF, make sure that you go and review that first. Then you're going to look for what's called a common binomial factor. It will appear after you factor out the GCF. And then you're going to factor out the binomial of GCF, which basically means once you take out that common binomial, you'll be left with your two GCFs, and that will create a second binomial. This will make a little bit more sense once we actually get into the examples on the worksheet, which we're going to do right now. Okay, so here we go. We're looking at four-termed polynomials. Again, grouping is something that you can only do at this point with four terms. So GCF factoring won't work because all four terms don't have something in common, and P's and Q's only works when you have three terms. So step one, we're going to put in our groups, which basically means we're going to put parentheses around the first two binomials, or the first two terms, excuse me, and the second two terms. So we just created a sum of two binomials. Binomial meaning two terms. Now we're going to find the GCF of both. So the greatest common factor of 12 and 16 is 4. So in the first binomial, 12x cubed is 4 times 3 times x times x times x. And 16x squared is 4 times 4 times x times x. Over here, 15 and 20 have 5 in common. So 15x is 5 times 3 times x, and 20 is just 5 times 4. Oh, and we're adding in between. I should actually note that. Okay, now we need to continue this step, so we need to find what they have in common. So in this case, it would look like they have 4 and x squared in common in the first one. So in the first binomial, I'm going to factor out 4x squared, and when I do that, it leaves me with 3x plus 4. Over here in the second binomial, they have 5 in common, and it's a positive 5. So when I factor out positive 5, I'm left with 3x plus 4. So all I've done so far is GCF factoring. That's it. I have factored out 4x squared from the two terms in the first binomial and 5 from the two terms in the second binomial. That is it. Now, this is not done because factored means written as a product, and this is still a sum. But step 3 is to look for what's called a common binomial factor, meaning these are two products, and these two products have a binomial factor in common. This is 4x squared times the group of 3x plus 4, and this is 5 times the group of 3x plus 4. Because these are in common, we can actually factor that out, and that's going to be one of the binomials in our final product. Now, just like we factored out the common factors here, once we factor those out, those are no longer a part of that step. And our final step, if you remember from the whiteboard, is to create a binomial of the two GCFs. So the second binomial here will be a combination of the two GCFs that we used. The first term will be 4x squared, and the second term will be positive 5. So what ends up happening here is when you multiply all of these terms, you'll end up with these four terms here. So like 4x squared times 3x is 12x cubed, and 4x squared times 4 is 16x squared. And 3x times 5 is 15x, and 4 times 5 is 20. And that's how we know that we factored this correctly. All right, let's go ahead and do another example here, because the more examples that you do, the easier that this becomes. Now, this one's a little bit tougher because you can't put groups in unless you have addition. So in order to make this addition, we're actually going to put that negative sign with the term, and then we're going to put in a placeholder addition symbol. So in order to do that, I'm going to have to rewrite this expression. So now, whoops, that's not going to do it. That's the box. I want the pen. So here we go. So I have 20a cubed plus 24a squared plus negative 15a minus 18. And again, we do that because of the associative property of addition, which states that you can't put groups in unless you have addition symbols. All right, now we're going to find the GCF. So 20a cubed and 24a squared have 4 in common. 20a cubed is 4 times 5 times a times a times a, and 24a squared is 4 times 6 times a times a. Over here, because it's a negative leading coefficient, we have to factor out a negative GCF. So they have -3 in common. So -15a would be -3 times 5 times a, and -18 is -3 times 6. Okay, what do they have in common here? So first binomial looks like they have 4 and a squared in common. So we're factoring out 4a squared. And when I do that, I'm left with 5a in the first term and +6 in the second term. Now, once you start getting good at this, you'll realize again, this should be my common binomial factor. So over here in the second one, I'm trying to get 5a plus 6. Let's see, these two have -3 in common. So adding -3 would make that a -3. And once I factor that out, look at what I'm left with. 5a in the first term and a +6 in the second term. And I have a common binomial factor. Without a common binomial factor, we cannot continue. But I have one, so that's good. Okay, so because that's what they have in common, that's going to be the first binomial in my product, 5a plus 6. Once that's taken out, I can create a second binomial using the GCF, 4a squared and -3. So my second binomial is 4a squared minus 3. We'll do a quick check here. Let's see, 5a times 4a squared is 20a cubed. 5a times -3 is -15a, which is that term there. 6 times 4a squared is 24a squared, and 6 times -3 is -18. So we are good to go. All right, last one that we're going to do, I'm going to have to move this down a little bit, and I have a feeling, yep, I'm going to have to get rid of these drawings first. Unfortunately, that's how it works. Okay, last one, number 17. Again, we have subtraction here, so I am going to have to rewrite this using addition. So we have 14k cubed minus 21k squared. Ooh, gotta connect that k. That's in a binomial. Plus -8k plus 12. All right, step 1 done. Step 2, GCF, 14 and 21 have 7 in common. 14k cubed is 7 times 2, and k cubed is k times k times k. 21k squared is 7 times 3 times k times k. Over here again, because it's a negative leading coefficient, we must factor out a negative. -8 and 12 have -4 in common, so that's -4 times 2 times k, and 12 is -4 times -3. Careful, make sure that you account for that negative. What do they have in common? Well, the first two have 7 and k squared in common, so I'm going to factor out 7k squared, and that leaves me with 2k in the first term and +3 in the second term. Again, I'm thinking ahead. This should be my common binomial factor in the second expression. Over here, I'm factoring out a -4, and when I do that, I'm left with a 2k minus 3. What happened there? Oh, you know what? I made a mistake, and I'm going to go back and find it. This shouldn't be addition. This should be subtraction because I forgot to account, whoopsies. I forgot to account for the fact that this is subtraction here. See, that's how you can make sure that you're doing it right, because you need to have a common binomial factor. Now I have a common binomial factor. So my first factor in my product is 2k minus 3. And once I factor that out, I am left with 7k squared minus 4 as my second binomial. Do a quick check just to make sure. 2k times 7k squared is 14k cubed, which is right there. 7k squared times -3 is -21k squared. 2k times -4 is -8k, and -3 times -4 is +12. So we are good to go. All right, that's the end of this video. Just again, the 4 steps for factoring a 4-term polynomial with grouping. Step 1, set up your 2 binomials. Make sure that there's addition between them. If there's no addition, you have to change it to adding a negative and put a negative with that second binomial. Step 2, factor out the GCF from both binomials. Step 3, find that common binomial factor and make that the first binomial in your product. And then step 4 is to find those other 2 GCFs and make it the second binomial. That's it for factor by grouping. And